This video is intended for entertainment and historical purposes only. It's not meant to be an instructional tutorial or provide professional advice. If I were to ask you what's required to run a steam locomotive, what would your answer be? I'm sure some of you are saying fire, water, and steam pressure, which is fairly accurate, but not entirely correct. No, the answer I'm looking for is controls. You can have all the fire, water, and steam in the world, but if you have no way of harnessing these elements, they aren't going to do you much good. The Davenports are simple little engines with only 3 levers: a throttle, a brake, and a Johnson bar. The throttle makes it go, the brake makes it stop, and the Johnson bar determines which direction you move. Between the 2 locomotives, we're missing both throttle handles and half the other controls. Today, we're going to start the surprisingly complicated task of replicating the missing controls.
So we're about to make a brake lever for the second locomotive. This one's been missing. This was originally a forging, and I'm going to have to replicate it out of solid steel, which is a long process. A shaper is a machine that hasn't been used for some time in North America. It's still used around the world. The old joke about shapers is that you can make anything in a shaper except money, which is pretty much true. They're very slow, but the tooling is dirt cheap, and they're very reliable.
A machine tool called a shaper may be used when surfaces are to be made flat. This way of working metal is called planing. In the shaper, the work is stationary.
Over here, we've got the rest of the levers and the parts and bits and pieces that we're trying to put together. We have two levers here for reversing and 2 brake quadrants with ratchets and only 1 reversing quadrant. We're going to have to make another one. As you can see, I've been munching away with the shaper, shaping this up. It's still a little bit thick. It's easy to take stuff off. It's a little more difficult to add it on. So now it's Sherlock Holmes time. This is number 2 as it was found, with the brake and the reverse lever. So this is the original reverse lever or Johnson bar. And as you can see, the eye is in the middle. Equidistant either side. This arm is the way it is. This is the brake lever, and as you can see, it is bent outwards to clear your knuckles. This is the original Johnson bar reverse lever off of number 1 from Punter Bay, and it was being used as a brake lever. And this is the pawl that belongs on it. And as you can see, it lines up, it's offset in the correct direction. And we know which way is forward on these because these supports all have to face forward. There's 3 of them. So I made the 4th lever, the brake lever, thinking, well, I would turn it around the other way to provide extra clearance for your knuckles, as you can see. However, this is the brake pawl off of number 1, and it doesn't fit because it's now facing the wrong way. So obviously on the Punter Bay engine, this lever was around the other way and probably bent the same as the engine 2. So if I turn it over like this, now the pawl, and we know it's the brake pawl because it's got grooves in it to match a latch for a brake. It does not fit the quadrant for reverse. Now it will fit. So this is obviously the way the lever's sat. I'm not so sure that there's enough knuckle clearance up there So probably I'm going to end up bending it outwards just the same as this one. When you get these engines, they're always different. I swear that when they get an order, they go into stores and see what they've got left over from other projects or out in the back lot and grab whatever will sort of work to build another engine. I have to make new pawls for the rest of them. There aren't any. And I have to make a new quadrant. So now it's all figured out. I got a bit wrong. I assumed that this shorter lever, this one here, was the reverse lever because it's the same length as the reverse lever on the other engine on number 2. When, however, it actually is a brake lever. It was installed as a brake lever. So I've gone ahead and made a completely new brake lever. I still have to do some milling out, which is the same length as the original brake lever. However, things aren't going to work too well here, so I have to actually cut this off and turn it over and mount it in the middle like this one is. You can see it's mounted in the middle and the holes on this side. Right now the holes on the back side, but the recess for the clasp is on the correct side, so I have to drill a new hole to mount these little guides that are used for guiding the pawl, and I have to cut this off in the hacksaw and re-weld it on in a central position so it matches the other one. So I'm in the process of milling out this slot. It consisted of drilling a hole at each end, 15/16, using this mill drill, which is 5/8, and removing the center section, and then moving it over and machining this side off. This is just under ½ an inch, 15-30 seconds actually. And now I've moved it to the other side. I'm taking and leaving 15-30 seconds on here, which will give me 1 1/16 inches. The bar that goes through here is 1 inch and it needs to move smoothly. So as you can see, this is the type of mill I use. It's a 2-flute mill or a mill drill that I can hand sharpen. I don't need any special tools to sharpen. This has been sharpened multiple times by me just on the grinder. And I just go back and forth until I have it all the way down to the bottom. And that gives me the slot that I need. So these are the new levers, or one new lever and one rebuilt lever for number 1. I've manufactured, as we've seen, an entirely new brake lever. This is the pawl that belongs on it. You can see it fits. This piece goes in here, holds it down. I've had to modify the reverse lever or Johnson bar by I cut this off, I welded it in the middle, and I've machined it slightly so that this will fit in here smoothly. The other side, which is the back side, has been machined to accept a new pawl, which I have not made yet. The interesting thing on these machines is that the levers is one forward and one back. Both handles go to the back, and I've had to machine out a new piece. So at the moment this is upside down. Turn it over. This is what you look at from the back. The pawl of the handle is up here, is at the back side to release it, but the straps on this one go to the front to operate this pawl. However, the straps from this lever stay down the back to operate this surface. So that's what got us all confused. So the next project is going to be to make the pawls that fit on here. I have to make one of these for the brake and 2 for the reverse, which actually have a gear tooth on them rather than a latch tooth. This is the pair of reversing levers or Johnson bars. And we're doing some repairs because These engines are equipped with Stephenson gear, and Stephenson gear, while being a very good valve gear, does have a lot of reactionary forces, which causes all the wear on all the links and pins, including the pin that's in the Johnson bar. And over time, these pinholes get worn, and everything starts clicking back and forth in time with the drag on the valve. And so what we're doing here is these holes here were drilled out 7/8, and they're not supposed to be that way. This is one of the originals. This is a 3/4 inch hole, and the other side is a 5/8. And the point is that the pin comes through from one side, and there's a nut on here that holds everything tight from moving. And this is a standard sort of Davenport way of doing things. So what I've done is I've built up the holes with weld, and I'm going to mill them back out to the proper size. You can't drill these out because the drill will just go all over the place. So I use a vertical mill, and I run a vertical milling cutter through. The way you weld up the hole is, you can't maybe see this, but you clamp a piece of copper plate or non-ferrous plate in here, and you weld down onto it. The weld won't stick to the copper plate, but it will fill the hole completely in the bottom, and you just keep building it back up. I use 70-18. You can use 60-10, 60-11. This was downhand, so 70-18 worked well. So what we're going to do here is we're going to put this in the milling machine. I've already had it in, as you can see, to surface this off. And I'm going to drill down through with a 5/8 milling cutter all the way to the bottom and finish this bottom hole at 5/8. And then, without changing anything, replace the cutter with a 3/4 cutter and cut this hole out to 3/4, and that way they're in line with each other. So here's a refinished hole. It's been welded up and built back up again. Now this is the pin. As you can see, it's stepped. It goes through, and a nut on the other side keeps the whole thing tight. And I think you can see the pin itself is worn. You can see where this motion I'm talking about, that's slipping back and forth, have actually worn the pin. So we'll make up some new pins for both locomotives. These just slip through and bolt from the other side. The nut goes on the other side to tighten it all up. But they need to be a good fit, because otherwise they're slipping back and forth this way. We're going to make up the parts for the latches or pawls that engage the reverse track here and engage the brake. We have one piece left over. This is actually the brake pawl off of one unit. And I have to make one more of these, and I have to make two to fit in this. Now, when these engines were built, the manufacturing concerns had a very large forging department. They forged everything they could. To specifications, and then the machinists would finish it off. And this is, of course, the case. This would have been a forging, and then the machine shop would have finished these surfaces and cut these teeth and drilled these holes and generally done everything. Well, I don't have a forging department, and this doesn't exist anymore, but you can make these parts up by building them with welded components. This is just mild steel. This has the additional benefit of, in assembling these parts. So this is the part that's going to be this, as you can see here. I've already cut the teeth in the end, and I'm going to weld this piece onto this piece and then machine the whole thing out. The advantage here is that a person can actually do smaller components in the machine tools that he actually has. For example, I have cut these teeth in the shaper, and these teeth are correct. They match the teeth on this one. However, the top tooth is a little tall because some of this material is going to get machined away back down to dimensions. So I had this in the shaper and was able to machine these teeth because I had a nice small piece that would actually go in the vise, and it was a simple matter of setting it up in the vise and cutting the teeth. Whereas a piece like this is much longer, much more awkward, and requires different tooling. These pieces, they have an end, a hole in them for the straps. They also have a threaded hole for this rod to go in. When this is all in one assembly, this is a bit awkward to drill in one big assembly. So what I've done is I have laid out these pieces with a mark for the side hole and the threaded hole, and I will do this in my drill press and get this all finished and machined before I actually weld it to here. So these will be finished before I put it in the mill and shape it to its final shape. These holes are to start the milling the slot out. These are the welded up components that we're going to make these pieces out of. This one gets made like this. I've welded them up and I machined the back so that they're flat. And now we'll go and gnaw off all the various extra material that doesn't want to be there, and it'll end up looking like this. So these are the 4 components we've been working on. This is the new one to replace this. It's exact copy. This is a new latch for the Johnson bar on each one. They're intentionally much longer because I don't know exactly how they're going to fit until the machine is assembled. And this one is offset slightly because the bar is offset slightly, and this needs to be straight up and down. And I'll have to make 3 of these to hold it down, and then I'm finished with this particular part. So that's how we did it. This new one, new teeth, everything seems to fit okay. Just a lot of whittling, really. This is my little Craftsman lathe. Some people know it as an Atlas lathe. This is an older model from the 40s. It's my first lathe. I got it when I was 12 years old. It had spent its life in a garage turning commutators for generators. It's a plain bearing head machine. What I'm doing at the moment is I'm turning material around so I can grab it in a big lathe to make bolts. So what we're about to do here is to take these pieces of 3/4 inch material that have to be milled down to 5/8 like this. So we're clamping this piece of material down in the material against the bed. This bed has been raised so it's 50 thou below the width of this material. I'm taking 50 thou off each side. The way you clamp things down on the milling machine is that the table has T-slots in it, and these fit in the T-slots, and you slide them in from the end, and that holds them down. And you have various attachments to hold it down. I use these. It's like an alligator that one fits to the other any height you want, and that's what's here. This machine is old and it's worn, and the gearbox is pretty noisy. It works fine, it's just got a noisy gearbox. It was built in 1943 for Boeing's in Seattle. It's done a lot of work since then. This is at Cincinnati MH2, I think it's an MH2. Yeah, it's an MH2, which stands for milling machine horizontal, but this has a vertical attachment. So that's one side done. There you have it. We've milled both sides off 180 degrees. It should be 5/8. So it is, I don't know if you can see that, but it's exactly 5/8. It's exactly what we want. So here's what I'm trying to accomplish. I'm trying to make one of these. This holds down these latches. Fits in the slot, as you can see. but it can't turn. It actually guides the latch back and forth. So I've got to recreate 3 of these. And so what I've done is, as you've seen, we've turned this down in the lathe and the little 4-jaw on the small lathe to grab, so I have something to grab in the big lathe. I've milled this 3/4 inch material down to 5/8 on 2 sides so that it will fit in here and slide back and forth to give me this little flat spot on either side. This is hard to do. They've done this afterwards because this was a forging. It's a lot of extra work. So what I'm going to do is I'm going to take this piece and I'm going to turn the very end here 3/8 round. I'm going to cut 3 plates and drill them out, and I'm going to weld this piece into the plate. And then I'm going to grab the whole affair and machine it. So I have a bolt. I'll round the ends a little bit. I'll make this as 5/8 bolt. I'll probably do this first. This is the way it sits. So there's going to be a little 5/8 square flat spot, and the rest will be machined and threaded to 5/8 bolt, 5/8 NC, and we'll end up with these pieces whose sole purpose is to hold down these straps to keep them from moving away from the brake lever or the Johnson bar lever. So you can see how it is on the other side holding it down. And so that's where we're going with all this. When you're doing these locomotives, it's the little pieces that take all the time. The big bits, everybody look, you seem to make great strides and progress, but it's the giblets or the small pieces that really take the time. So these are the completed parts. The square parts left. We've drilled out the back plate and welded it in. It's 100% weld. And it's ready to be fitted up. So we're working on the reverse lever. This is the piece that goes in. It fits in this slot, and now I have to fit this. This is too loose, and what's involved is carefully machining this off a little bit at a time until this is just tight, and it's still free, so it can slide back and forth, but still tight. So this is one of 4 completed latches. This is for number 2. This is for the brake lever. It moves back and forth. It's a little stiff, but it just needs oil. It's supposed to be springs in here. We haven't got them in yet. But it works really well. We're pretty sure it's in the right place. So that's the completion of all 4 latches. They all look the same when they're mounted. So now I have to sit down and I have to make the hasps for this end. This one's upside down. I've gone ahead and made one up. Fits in here and works as a lever.
And that'll be a wrap on today's episode. Join us next time when we complete the handle project. Thanks for watching right to the end of the video. Here are a couple other episodes from the series. And don't forget to subscribe, leave me a comment, and hit that bell icon so you don't miss out on future episodes.